That roof is on fire. So from the previous tutorials we've been having, we've been working with this relationship, right? So I think you guys understand this relationship now, but if you don't, please feel free to ask. So this is our inheritance relationship. So a lot of, or rather everything we're going to be talking about is going to be stemming from this inheritance relationship, right? This is, yeah, okay. This is when we have a parent class and then we have two base classes, right? So in this example, I'm just going to make an example for a class called shape, right? We have this class called shape. We have this class called shape. Let me make it a bit bigger, right? And then we have these two. So we'll have one called rectangle and also one called triangle, right? Like that. So what happens in this case is we have this parent class, right? So I think everyone can agree with me that this parent class, or rather these two things are shapes, right? So this is a relationship. So a triangle is a shape, a rectangle, yeah, there's an N here, and a rectangle is a shape, right? So this is our is a relationship. So this is our inheritance relationship, right? Now what happens with our inheritance relationship? We know that the stuff or the members that are stored in this parent class are going to be inherited by these child classes. What that simply means is whatever is in here, these two classes have them automatically, right? So for example, if we have variables called name in here, which are protected, so you remember that protection access modifier, we'll look at those. Remember we had private, public, and then the protected ones, right? So this is where they come in. So let's say we have this variable called name, right? These two classes, right? These two derived classes are also going to have a name, right? But then because of the inheritance, we don't need to save the name in these classes, right? So the name is only going to be saved in the parent class, right? We don't need to we don't need to redeclare a name variable in these two classes because we already have it in the parent class. And because these two classes inherit this class, that means they're going to inherit the name, they're going to get the name, right? So there is only one name, right? Or yeah, there's only this variable that exists, right? Think of this almost, it's not the same thing, but think of the idea as like the static members, right? The static members are members that are available to the entire class and all the instances, right? Same thing with variables in the parent class. Those variables are available to all the children classes or all the attributes. So you can think of this as the class. This is just an analogy or an example, so it doesn't work like this. You can think of this as a class and these as the instances of the class, right? And this being a static member, and that means that these rectangle and triangle have access to this name, right? The only difference or caveat is that because or this aesthetic member cannot be edited, right? Or it can be edited, but everyone will get the same variable. So if the stat, like in a class and object relationship, like what I'm talking about, the name will be, everyone will have the same name, right? So if the name is, let's say, Peter, this will have access to Peter, this one also Peter, right? So it does not work exactly, but it's the idea, right? That we only have this one thing and everything shares that one thing. So we don't have to save name in these derived classes, if that makes sense. Or did that make sense or was I rambling? Uh, okay. Now with polymorphism, what happens now with polymorphism? Polymorphism works with functions, right? So let's say we have a function called draw, right, in this base class. Uh, yeah, we have a function called draw in the base class. and let's say it's protected, we'll also have a function called draw in the derived classes, like this. So we'll have a draw here and also a draw here. But I think you guys can agree with me, right? That uh, the way you draw a rectangle is not the same way you draw a triangle, right? Meaning to say that this rectangle, it is going to redefine this draw function in its own way, right? And then this triangle is going to redefine the draw function in its own way, right? That is essentially what polymorphism is, right? Polymorphism is this idea that we have one function, right? Same function prototype, right? So it's going to have the same name, it's going to have the same return type, it's going to have the same parameter list, right? But each class defines it in a different in its own way, right? That is polymorphism. Even like the name of the idea itself, means many, and then morphism means change, right? To change. So you can think of that as many states. So this function has many forms, or it has many states, right? It can draw a rectangle and it can draw a triangle, right? That is what polymorphism is. Now I see the question here is about the slicing problem. Polymorphism does not cause the slicing problem, but we'll get to that on Wednesday, right, when we're doing everything, right? So that is what polymorphism is. Do you guys understand that part of polymorphism? Before I move to the next one, right? Polymorphism is this idea that we have a function that has many forms, right? So if, for example, you see right now let's say this is our program, right? It only has rectangle and triangle and shape, right? Let's say this draw function, or let's say we started off with one shape, right? Let's say this triangle shape didn't exist. We started off like this, right? We just discovered that there's a shape called rectangle, right? And then we have this draw function, and then this draw function knows how to draw a rectangle only, like you define it in this case, in this one here at the top. What happens when you add now the triangle? This draw function won't work, right, for that triangle. What if you were to add a square? What if you were to add a hexagon, a pentagon, right? This draw function won't be able to do that. Hence why we have to redefine it in that specific class, in those derived classes, right? So that is polymorphism. And I want you to notice there's two ways that I said here. I said this draw function, the draw functions in the derived classes, right? So draw functions in the derived classes redefine this draw class, right? So they redefine. This is very important, right? Because when we are just working with classes like this, or just normal functions like this, when the classes have the functions in their own way, it's called the redefinition, right? But now we are moving on. Now they're asking us to create abstract base classes, right? Now, how do you create an abstract base class? An abstract base class is essentially a base class that has one or more purely virtual functions, right? Now, I'll go over these more in detail on Wednesday. So right now, I'll just explain. A purely virtual function is a function that is not defined in, excuse me, a function that is not defined in the base class, right? So you remember how we had, for example, I think it was the flag illustrator, right? The flag illustrator was, um, what is it? It was also, you could generate an image with the flag illustrator, and then it'll give you the color one, right? And then the black and white will make the black and white one, and then the grayscale will make a grayscale one. That was just a normal function. Now, if the function is purely virtual, it means that in the base class, the function itself does not have a definition, right? So the base class cannot define that function, right? Now, when a class becomes abstract, right, when it has one or more purely virtual functions, meaning it has one or more functions it cannot define, it does not know how to define them, or it does not define them. What happens with that now is we cannot create an instance of the base class, right? We can only create an instance of the derived classes, right? Because if the class does not know how to define this function, we cannot create it, right? So we need to create a class which knows how to define everything, which knows how to define all of its functions. Now here's where that word comes again. Now when we have a purely virtual function, right? So imagine this is a purely virtual function. I'll just write I'll just write this is a PV now, which means purely virtual function. What happens now is that this class is purely virtual, right? It does not have a definition here anymore. Now, when you have to now notice this, we are no longer redefining it, we are overriding it, right? So if the function in the base class is a purely virtual function, right? We don't redefine, because redefine means like we are defining it again, right? We are now overriding it, right? So that is something you have to just keep like you have to keep that in your head, right? If it's a normal function in the base class, in the derived classes we redefine, and if it's a purely virtual function in the derived class we override, right? So yeah, I think for the practical, this is all you have to know. This is yeah, all you have to know. So is there any questions here before I move to the code now? Is there any questions? Any questions on polymorphism? Any questions on abstract class? Okay. No questions. So I'm guessing everyone understands. And again, yeah, if you don't understand, please, yes, yes, Poteho, you can ask your question. Okay, let me just move to the chat. Can you repeat overriding? Okay, overriding is essentially the same thing. Was someone saying something? Okay, so overriding is the same thing as redefining the function, but the only difference is now in the base class, the function does not have a definition, right? It is purely virtual. So when a function is purely virtual, it means that in the base class which the function exists, there is no definition in it. Right? If this was a normal function, let's say you say shape.draw, and then this just draws maybe a circle or just a random, you just draw something, right? But if it's purely virtual, this function does not have a definition at all. Like you don't even define the function, you don't implement it, right? If it was the header file and the CPP file, you will write it only in the header file, and in the CPP file, it will not have what's the word? It will not have an implementation in the CPP file. So overriding is redefining a purely virtual function. That's what overriding is. Does that answer your question? Okay. Let me just check. Okay. So another thing you have to know is how to make what they call polymorphic calls, right? So a polymorphic call is, remember I said that polymorphism is the idea that a function has many states, right? So even with the purely virtual functions, it's still the same thing. We still have this function and then it still has many forms because it's still gonna draw for a rectangle, it's still gonna draw for a triangle. Now what happens with polymorphism is you create a variable which can hold the shape, which can hold a shape class, right? Now remember that a rectangle and a triangle are a shape, right? So if you create a variable called something something and then it is of type shape, you can create a rectangle and then store it in that variable because a rectangle is a shape, right? So because the variable is of type shape, we will see that now when I open the code. I think it will be more clear then even. When you open that variable that stores, so let me just do this. So imagine this is a variable. Um, so imagine this is a variable of type shape, right? So when I say this is a variable of type shape, so imagine just a variable called like a integer variable or a string variable, right? That is a variable that is able to store a string or a variable that is able to store a integer, right? Or a variable that stores a string or a variable that stores an integer. Now this variable stores a shape, now, right? Now, because a rectangle is a shape, you're able to store a rectangle in this variable. Because a triangle is a shape, we are able to store a triangle in this variable, right? Now, a polymorphic happens when, because this is a shape, right, you can call this function, right? And then remember, with abstract base classes, you cannot create a base class. So this shape variable will only store a rectangle and a triangle. We're going to see that now. And when it stores this rectangle or triangle, it's still a shape variable, right? But we're able to say shape.draw. And then depending on what you have stored in that variable, that function is going to get called, right? So if you had stored a rectangle in this shape variable and you call the draw function, it's going to call this draw function in the rectangle. If you had stored a triangle in this shape variable, it's going to call this draw function, right? uh, do you at least understand the idea of what a polymorphic call is? A polymorphic call is, we have this shaped triangle, but depending on what is stored inside, we can call different functions, right? Uh, okay. Does everyone's preg 4 work properly? Does everyone's preg 4 work properly? That's my first question. Because obviously our this preg 5, I'm guessing this is preg 5, is gonna, or preg 6 rather, it's an extension on preg 4, right? So I don't want uh you not to be able to submit this one because preg 4 is not working. So if your preg 4 is not working correctly, right, please do message me or even on the group, right? And then so that everyone's preg 4 can work, and then we get to preg 6. So preg 6 is very simple. Everything is gonna be the same. Well, we're gonna change just a few things, right? So I've already done this, so please follow along, and then I will see you what has changed. I'll show you what has changed. And then if you're still confused, please do ask me. Uh, yeah. So, okay, and then another thing before I forget, right? Now, remember I said you cannot create an instance of the base class because it's now an abstract base class, right? It cannot exist on its own. Like, the base class itself cannot exist. What's going to happen is that when you create a triangle, right? Remember constructor chaining, right? When you create a triangle or a rectangle, what's going to happen is you're firstly going to create the base class and then create this rectangle, right? And then this rectangle is uh, you can say, is going to be bound to the base class that it creates, right? So when you create a rectangle, technically there are two objects that are existing, right? When you create the rectangle, it also creates the shape, and then remember, the shape is the one that's going to store the variable with the allocated memory. In our context, the case of the flag illustrator, remember that. So in this case, the shape will be the illustrator or the flag illustrator, and then these two will be like the black and white illustrator and the grayscale illustrator. And then remember, in the base class, that's where we stored our image. And then remember, with our image, or our image, we had to allocate memory, right? So same thing. When you allocate memory, you wanna deallocate the memory, right? So whenever we create a rectangle, the rectangle itself is gonna create the base class, and the base class is in extension gonna allocate memory for that variable that is stored inside here. So meaning that we need to deallocate that memory, right? So when we delete this rectangle class, this rectangle class must also delete the base class, which will in turn deallocate the memory, right? So in order to do that, what we do is very simple. You just make this flag illustrator virtual, the destructor rather, or the destructor of the base class, you make it virtual. By making it virtual, whenever you create either one of the derived classes, what's going to happen is, when you delete that derived class, it's also going to delete the parent, right? I hope that makes sense, right? So your first change is going to be to go to your base class, right? So in this case, our base class is Illustrator, and then Grayscale Illustrator and B Black and White Illustrator are derived from this class, right? So you go to the base class. So nothing changes here. What you only are going to change is you're going to add this virtual. You're going to make the destructor a virtual function, right? So that's what you're going to do. And then now remember, if you look at the practical, it's asking you to make this base class a abstract base class, right? And how do we make something an abstract class? We have to add one or more pure virtual functions. So we'll go to our class and then we'll look at our functions. Which functions can be purely virtual? And then if they are purely virtual, it means that those functions must be redefined, or not redefined, they must be overridden in the derived class, right? Now, because the function, or rather, the only function here that is redefined in the base, in the derived classes, is this generate image class, right? So you can even just go to your either one of your illustrators and look for a function that is in the parent class, and then in this case you can see that it's the generate image. Even in this one, it's the only other function we have, right? That means this is the one that was getting redefined, right? But now, since we're going to make it a purely virtual function, it's not going to be overridden in those two classes, right? So how do you make a function purely virtual, right? So if you have a function like this, for example, I'll just make an example here. Your function will have a return type, right? And then it'll have the name of the function, and then it'll have the parameter list, right? The list of parameters they expect. And then it'll also have maybe if it's const or something, right? This is optional. Not, or rather, not all classes are going to be const, right? So it'll usually have these things. So you have the return type, the name of the function, and if it's const or not, right? Uh, so how do we make this function a purely virtual function? So what you do is you put virtual in front of it. So in front of everything. So if this was a void string, you put void in front of the whole thing like this. You have now void, no, not void. You put virtual, sorry. Virtual in front of the whole class like this. Yeah, the whole function, right? You put virtual. So this is now a virtual function. But to make it purely virtual, like a pure virtual function, we have to equate the function to 0. Now this becomes a purely virtual function. So I'll just do this and say this, where's my cursor? This is a virtual function. Now what is the difference between a virtual function and a purely virtual function? Right? This is something, again, I will cover on Wednesday in detail. Pure virtual function. The difference is that a virtual function can be defined in the base class, right? Or it does not necessarily have to be overridden in the it does not have to be overridden in the derived classes. And then a purely virtual classes must be overridden in the derived classes, right? So I will explain that more on Wednesday, and I'll give you maybe some use cases of why you might want it to be virtual and not pure virtual, and why you might want it to be virtual, and all right, what vice versa, right? Why you might want it to be the other one and not the other, right? So like I said, the first thing we need to do is come here to our destructor, make it virtual, and then the function, now you need to find the function that is being redefined in the derived class and make that a virtual function, or all the functions that you want to be overridden, make them pure virtual functions. So you just add virtual here in front of the whole function, and you equate that function to 0, and you put the semicolon after. So the semicolon is not here. The semicolon is after the entire thing, right? And then another thing you need to do is you need to remove the definition of this function, right? We had defined this function somewhere here, right? We had defined it to print out the 2 ppm for the image. I think if I remember correctly, this function was printing out the color to ppm, right? So you need to remove that definition because remember a pure virtual function is not defined in the base class. So you need to remove the definition. So if for example this was the definition here, you remove this entire thing, right? You like remove it, and then now your function is pure virtual. Now if it's pure virtual, meaning that in your base classes you must override it, meaning or you must redefine, you must override it in your virtual function, in your derived class, sorry. So the next step is to go to your derived classes. You locate again that function that is being overridden, or yeah, that is coming from the base class, and then you add virtual in front of it just to show that this is the function that we are overriding, right? We put this virtual in front of it. And then now you need to implement that function. We had already implemented the function, so we don't need to do anything. Yes, I don't know who raised their hand first. I'm guessing Nicolette raised first to last. Okay, so that's Potejo, then Nicolette after. Okay, Nicolette.
Sir, Ganti, don't we put override after thingy at the what you call this after the generate image thingy because it's the one it's redefining the other one.
Yes, so here like this.
Yeah.
Yeah, so yeah, yeah, you can, how can I say this? Yes, for comp sci 2b, 1b, yes, you must do this. Yeah, I had missed that actually. Yes. Thank you for that. So just to show that this function is getting overridden here. So that means also in our other derived class, you must have override.
So like say we write the virtual and override in the same thingy.
Yes, it should be like that. Yes, let me just confirm on my side. Did you guys have a tutorial or anything about this yet or nothing yet? Okay. I'll check if this works actually. Let's check if this works. Um, where's my stuff? Where's my stuff? Let me see if it's working. Yeah, it's still compiling. Okay. This thing's still compiling. So it works. Okay. Uh, let me see if it's gonna open the images. So you can write virtual. So you have to write override. Yeah? But for virtual, you can write it or you can leave it. So if you remove it, it's still gonna work because in the base class it's a virtual function, right? So it's gonna remain virtual in the other ones. So you can put this or remove it, and the function should still work properly. Let me close this stuff so that this thing is taking its time. Um, okay, this is that. Now it's opening GIMP. Okay, but then yeah, it works. So yeah, so we're in the derived classes now, right? So in the derived classes, you have the function, and yeah, I had missed this. You have to write override, but it should work either way. But just put it because they want you guys to do what you teach them, or what they teach you. They want you guys to do what they teach you, right? So we'll put it there, and then it works. Uh yeah. So here's the image, the grayscale one, right? So I'll just keep this here. Okay, so that's what you put now in the derived class, and then we don't do anything else in the derived class. So this generate image, since we had from what's this, from the last practical, right? We already had the implementation, so we don't change anything, right? We just made the function virtual, or all we did was we removed the definition from the base class, and then we made it pure virtual, right? But everything else stays the same, right? um Yes, and then here we just also make this a virtual function and override, or just keep it, just say override at the end, right? And then now this function is going to get overridden here, right? Um, Now the other changes are going to be inside main, right? Now remember, okay, I had already changed my main, but if you could remember, we had another case where we created a flag illustrator, right? And then that flag illustrator will just create the color, will just print out the color, right? But now remember I said an abstract base class cannot be created, or an instance of that base class cannot be created, right? So what's going to happen now is you're going to have to okay, it's okay. You're gonna have to change your switch, or your switch, your switch statement, your case statement. Yeah, it's not only gonna have a case for the grayscale illustrator and a case for the black and white illustrator. You can only create these two illustrators. You cannot create the base class on its own, like it cannot exist on its own, right? You can only create the derived classes, right? But in order for us to have that polymorphic call, remember I said we want to create a variable that stores the base class, or that stores a type of the base class, right? So this is what we did here. So this is essentially the same as saying int age, right? This is like saying int age, right? We are creating a variable called illustrator that is able to store a flag illustrator, right? And then you see when we create a variable like this, technically the variable is null, or it doesn't have anything, right? Same thing here, it doesn't have anything. But then when you now say age is equals to 10, now you're giving that variable something, right? Now it's storing this 10, or it's gonna store whatever you're gonna give it, right? So that's the same thing we're gonna do here. We're creating this variable called illustrator that is going to store a flag illustrator, but we have to store it as a pointer, right? Yeah, because pointers, C++, very fun, right? So we're going to store, or we're going to create this variable, or this pointer variable that is able to store a pointer to a flag illustrator. So by it storing a flag illustrator, it can store a flag illustrator, it can store a black and white illustrator, it can store a grayscale illustrator. And what I'm going to give you guys as homework, so the first homework that I'm ever going to give you is I want you to create a color illustrator, right? Because remember the color printing the image in color was handled by the base class, right? Now we can create a base class, right? So we need to create a class that must create a color, that must print out the image in color, right? So what we did here is we are creating a variable that is able to store an illustrator, any type of illustrator, right? Now this is where the polymorphic calls are going to come. Now this same variable, it can store a grayscale illustrator, or it can store a black and white illustrator and still work fine. So what we need to do is after creating the variable, you see, when I've created the variable, I'm not assigning it to anything, right? Now, if the user chose 0, right, they want the grayscale illustrator. If they chose 1, they want the black and white illustrator. This is gonna come from the arguments, right, the command line. Right, that's why I wanted you guys' Prec4 to be working properly. So if the user asks for a grayscale illustrator, what you're gonna do is you're gonna take your illustrator variable that is able to store illustrator, and then you're gonna give it this new keyword is gonna create for you a grayscale illustrator, and then uh, put that grayscale illustrator in this illustrator variable, right? Now this illustrator variable is of type base class, is of type flag illustrator, right? Now this is now the polymorphic call. You can even like comment it here so that when they ask you where is your polymorphic call, right? Right. You see, we have created the grayscale illustrator. We have stored it in here. Now, when we call the illustrator, we're saying illustrator generate an image, right? Now, because of polymorphism, right? If we create a grayscale illustrator, this line here is gonna call the generate image from grayscale illustrator. However, if we create a black and white illustrator and store it inside Illustrator, this line here is going to call the generate image of the black and white illustrator. But you see that it's still the same function, it's still accepting the same parameters, right? But the function is going to be a different, is going to have, is going to do something different because of which class is calling it, right? So this is polymorphism, and this is your polymorphic call, right? Did that make sense to everyone? Right? So we have created this illustrator variable that can store any type of illustrator, and then we store a grayscale illustrator, a black and white illustrator. Now, you see that this is a grayscale illustrator and this is a black and white illustrator, right? We both know that these two are flag illustrators. That's why we can do this. Now, if you were to say grayscale illustrator here, right, instead of flag illustrator, you say grayscale illustrator, and you try to put a black and white illustrator inside a grayscale illustrator, that won't work, right? Because a black and white illustrator is not a grayscale illustrator. However, a grayscale illustrator and a black and white illustrator, they are flag illustrators because they are derived from this class, right? So this is why this is possible. All right, and then this is just your default case, and then afterwards you're gonna need to delete the illustrator, right? And then whatever is stored in the illustrator, so if this is the grayscale illustrator, when we delete the illustrator, this is gonna call the destructors of this grayscale illustrator, and then the destructor of this grayscale illustrator is gonna essentially call the destructor of the base class. That's why we needed to make it virtual, so that we just call this once, right? And then that should be the entire practical done, right? But now, because us printing the image in color, we had done that. Let me see my time. Okay, we have 17 minutes. For, yeah, remember that the color, printing the image in color was done by the base class, right? And then we cannot have a base class. So your homework, right, would be after you have done this and it's working, you must create now instead of you must add another illustrator. You can just call it C illustrator for color illustrator. And when you call it or when you generate the image, that illustrator must now create or bring back or print the color image. Does that make sense? It must now print the color image because the color stuff was handled by the base class, and now we cannot create an instance of the base class. So we need to create a derived class that's gonna handle the color part, right? And this is in main, right? So it's gonna be something similar to this. You're just gonna maybe even copy all this and then now create a class called color illustrator, and then create its constructors, and then create this function that you're gonna override, And then when you override it, you're gonna still illustrate the flag. After that, you're gonna do this, but this must be for the color, right? If you remember how the flag illustrator did it for the color, this should be very easy because you're not gonna be doing anything. You're just gonna be calling functions which are already exist, right? Yeah. So and then that should be it. And then if you open, yeah, your if you run your program, right? Let me just open it here. So if I go to my batch file, you see my here is my command and arguments, right? If you remember, this 0 is gonna be the illustrator that I want, and the second number is gonna be the flag that I want, right? So if I go to my main and I open here, so the mode is the illustrator that I want, and then the second argument is gonna be the type of flag. So right now I have mode in grayscale, then the image is image 1, which is 1. So this is 0 1. So we have Japan, right? So if I were to run this, which I did, you get this Japanese flag in grayscale, right? If I change that, so if I come here and then I do this, so if I come to my batch file and then I say I want a black and white, but maybe of the, I think this is the Nigerian flag. Then I save this, then I come here and then I run it. It's gonna open the command thingy. There's no errors. There shouldn't be any errors, right? Then it created everything that it needed to create. Then okay, we'll just wait here. Then we'll wait to see if it opens the black and white Nigerian flag. Okay, it's taking its time. Okay, I think it's because I have a lot of things open. Let's just wait. So it should have, we should see. Let me see actually. We should see the black and white Nigerian flag if it's gonna open this thing. Yeah, there we go. The black and white Nigerian flag. And then that should be it. So on Wednesday, we will cover everything in detail. So on Wednesday it will just be a lecture because for this preg we're done. So I'll open the floor to questions. Any questions, comments, contributions? And then during recess, so during recess we won't have any classes. But I will be sending you past papers, notes, resources, so you can study. But it's recess. It's supposed to be taking a break. So yeah, no questions today. Questions, guys. Questions. Yes. Let me just open. Yes, I did record. I am recording. So I'll post the video now. Okay. Uh,
Sorry, sir. Can you
yeah.
hear me?
Yes.
Yeah, yeah. Can you just explain the parts of the base class again? Because it sounds like you're saying that we no longer need the base class that much, and yeah, you are referring to an abstract class. Can you just clarify that part?
Okay. So what's happening now with the base class? And I deleted that thing. Okay. Yes, so the base class now exists in an abstract manner, right? Meaning to say, uh, where is this thing? Okay. So the base class exists in an abstract manner, right? Meaning to say, its only job now is essentially just to provide information for the derived classes. The mere, or rather, how can I say this? Because there is now a pure virtual function within the base class, that means that the base class cannot define uh, that function, right? Because we said if it's a pure virtual function, that function does not have a definition, right? So when it does not have a definition, the base class cannot define that function, right? So that function is only defined, and then we said again, it's no longer defining or it's no longer redefining, it's now overriding. When there's a pure virtual function, it's now overriding, it's not redefining, right? Because you cannot redefine, you cannot re, yeah, you cannot redefine something that is not there, essentially, right? You cannot redo your work if you've never done the work, right? So if there is no code to redefine, we're going to call it overriding, right? That's why we change from redefine to override, because the pure virtual function a does not have a definition in the base class. Now, this base class exists merely just to provide members to the derived classes, right? So no, it's not that we don't need it. We do need it because everything about the two derived classes is in the base class also, right? If I can open the code, we do need it because all of these things, so this is our base class, right? All of these functions are in the base class. All of these protected members are in the base class. The image itself is in the base class. All of these functions are in the base class, right? So we do need it. But what I'm saying is now this base class cannot exist. Like you cannot create a flag illustrator anymore. You have to create one of its children, right? Because of this function, right? So that is what I'm saying. It's do needed. It's because if you now remove it, these functions cannot work, cannot do anything because they cannot illustrate because that illustrate is in the base class. They cannot edit the image because that image is in the base class, right? So everything that is stored in the base class is still in the base class and it's still important, right? But the only change we've made that is now this base class cannot be created itself. Like you cannot have an instance of the base class, only the derived classes. Does that answer your question?
Yes, I understand. Thanks.
Okay, no problem. Did you answer the question of the slicing problem? So no, the slicing problem I had said I would leave it for what is it? I would leave it for Wednesday when I'm going through everything in detail. Any more questions? Okay, I'll just touch on it so you can think about it. So the slicing problem, think of some you have this object, right, that has a lot of things in it, right? The slicing problems come the slicing problem comes when you the slicing problem comes when you slice away some of the things, right? For an example, let me see. It's just that our functions right now or our classes don't have anything that might cause the slicing problem. Um, da, 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 da. Hmm. Yeah, so I think we'll leave it for Wednesday and then I'll explain everything in detail then. Okay.